Hello and welcome to our lesson on applications of solving by factoring. So what we're going to look at in this particular topic is word problems, solving word problems using the factoring process. So we're calling these applications because it's going to give us a chance to apply our solving skills to a new situation. Now, word problems can be challenging because there isn't exactly one set of steps to solve every problem, right? Depending on the wording in the problem, you're going to have to go through a different process to set up an equation. And that's, again, what makes these challenging. However, there is a general set of steps or general strategy that we can use when we approach a word problem. In general, the first thing we want to do, which this may sound silly, but the first thing we want to do is read the problem. Sometimes we get so excited, right, that we want to just kind of speed through the problem and start writing things down and try working on it. But let's read it maybe even a couple times so that we understand what is given to us and what the question is asking us to find. And what it's asking us to find is going to help us define a variable. What we're asked to solve for is going to be the variable in our situation. Now the hard part obviously is going to be writing an equation to model the scenario. At least in this section we know we're going to be writing a quadratic equation, but the translating of the words into an equation is definitely the hard part. Now if we can successfully do that step, then the solving is review. The solving by factoring is the process we've already talked about that we're going to apply here to these new situations. And once we've solved, because now we have context in our situations, we want to make sure that we answer the question with an answer that makes sense. Okay, so we should have a reasonable answer. We should be answering the question in a reasonable way. Okay, so the first few examples we're going to try here are geometric examples. I like geometric examples because we can generally draw out what we're looking at. Alright, so let's look at number 1. It says the width of a rectangle is 4 feet less than the length, and the area is 96 feet squared. We want to find the dimensions of this rectangle. So when it says to find the dimensions, that means we're looking for the length and we're looking for the width. Okay? Now that's technically two variables, but we don't want two different variables in one equation that we're trying to solve, right? We want like an x and an x squared, but I don't want an x and a y, for instance. So we have to figure out which one of these dimensions is actually unknown and which one we know something about. So if we go back, it says that the width is 4 feet less than the length. So that means I know something about the width. The width is 4 less than the length. But do we know anything about the length? We do not. So since the length is completely unknown, we haven't been given any information about it, then that one's going to represent the variable in this problem. So let's call the length our variable. I'm going to call it L so I know exactly what I've solved for once I've solved, okay? Now because again this is a geometric problem, this is a rectangle problem, let's draw this out. So the length of the rectangle, they said we're going to call it L. I'm going to put it here. And it says the area is 96 feet squared, so I'm going to go ahead and label that in there. Now the width, this remaining dimension here, it tells me that that width is 4 less than the length. So the length that I put here, this dimension is 4 less. So how do I say 4 less than L? Well, that would be L minus 4. Take 4 away, 4 less. Okay, so there's our picture. Now, how do we make this an equation? Well, we're going to use the area, okay? We know, well, hopefully we remember that the area for a rectangle is length times width. So in this case, the area of 96 is going to equal the length times the width, but the width we said is the length minus 4. And now we have an equation. If we distribute the L here, L squared minus 4L, and we subtract the 96 over, then we have an equation that we can solve by factoring. So we have L squared minus 4L minus 96, and let's apply our bottoms up process here. So we're going to look for factors of negative 96 that make negative 4. Let's see, 12 and 8 make 96, and if I make the 12 negative, they multiply to negative 96 and they add to negative 4. And dividing by 1, we see this is going to factor into 1L minus 12 and 1L plus 8. Now those are our factors. Our solutions are what's going to cancel those out, right? What's going to zero those out. So a positive 12 will cancel the negative 12, and a negative 8 will cancel the positive 8. So we've got two solutions, and if we had no context, we would just box those in and go about our business, say those are our two solutions. But here, we can't have two different lengths for one rectangle, so one of these lengths has to be excluded as a possible answer. And hopefully you recognize that this one cannot be the length of our rectangle because it's negative. You can't have a negative length of a rectangle. So we're just going to exclude that from being a possibility. Length can't be negative. Be negative, so we're just going to discount that guy, say nope, can't be you, which means our length has to be 12. So we're going to say our length of our rectangle is 12 feet, and then it asks for both dimensions. What does our width have to be? Well, if our width was 4 less than our length, then our width has to be 8 feet. And if in fact we multiplied 12 feet by 8 feet, we would get 96 square feet. Okay, so there we have it. That wasn't so horrible. That rectangle is pretty bad. Let me use my cheat tool here to make a nicer rectangle. Look at that. It's cheating, I know. Okay, so next guy. We're going to do the same thing, but I made a little typo. I've luckily caught that before we go into the video here. This one's going to be a triangle. So the height of a triangle is 9 more than its base, and the area of the triangle is 56 feet squared. Again, we're looking for the dimensions. This time the dimensions are going to be the base and the height of our triangle. But again, two variables, not going to be good in our equation. So we have to establish which one of those is actually the variable. Which one is the variable? Well, just like before, they tell us that the height is 9 more than the base, but we don't know anything about the base. So the base is going to be our variable. So let's call that base B. And I'm going to use a capital B just because my little b looks like a 6, okay? And again, we know the area is 56. Let's set up our picture. See if we can't... That was bad, guys. Really bad. I can't even draw a triangle. Let's try again. Okay, too small. 3 times the charm. Alright, that's gonna have to work. Okay, so the base is B. So let's call this base B. The height is from the top down to the base here. That height, we said is 9 more than that base. So we're gonna put for the height here, the base plus 9. 9 more means add 9. And it says that our area is 56 feet squared. So now we need our equation, which again is going to be for that area. The area for a triangle is 1/2 times the base and the height. So in this case, 56 is going to equal 1/2 times the base, which we said was still B, and then times the height, which you said was our base plus 9. So now, before we distribute, I don't know if this is an issue for you, but I don't like that fraction. I don't want to have to distribute the fraction, and I don't want to have to factor with the fraction. So I'm going to get rid of this fraction, and as long as whatever I do to one side of the equation, as long as I do it to the other, I can keep the balance in the equation. So if I multiply both sides of my equation by 2, what is 1/2 times 2? It's going to be 1. So that's going to give us 1b times b plus 9 on this side, which is a little more manageable than the half. And then on the other side, the 2 times 56 is going to give us 112. So the fraction's gone. And now I'm going to distribute. So b times b is b squared, and b times 9 is 9b. I'm going to subtract the 112 over, so I can get this thing in order and equal to 0. So that cancels that. So I have 0 equal to b squared plus 9b, then minus 112. So let's try to figure out the factors now of a negative 112 that are going to add to a positive 9. So that's a larger number. Finding the factors can be a little more challenging. Let's see, we originally multiplied 2 and 56 to get it. Obviously, that's not going to get us a difference of 9. But if 56 is a factor, then factors of 56 will be factors. So I know like 8 will go in, I know 7 will go in, for example. So let's try 8. How many times does 8 go in? That would be 14. Still not a difference of 9. Let's try 7. 7's going to go in 16 times, there we have it. There's a difference of 9 between 7 and 16. So we're going to make the 7 negative, and dividing by 1, we see that this factors into 1b minus 7, and then 1b plus 16. So that means b equals 7, we'll cancel that one out, and then b equals negative 16. So 7 and negative 16 are our two solutions, and without context we would keep them both. But here, we're not going to have two bases for one triangle, and we know that our base can't be negative. So the base can't be negative, so we're going to exclude that answer from being possible, which means that our base is going to be 7. So our base is 7 feet, and then our height was 9 more than that. So 9 more than that, 9 more than 7 would be 16 feet. And if we multiplied 7 and 16, we would get 112, and then if we cut that in half, that would give us the area of 56 that we were supposed to get. Okay? So hopefully not terrible. Here's another one that I would like for you to try. Not the whole process, I just want you to be able to set this up. So if you're feeling okay or even semi-confident, then go ahead and pause the video and see if you can set up the next problem. Otherwise, we can attempt this together. So a rectangle is 2 times as long as it is wide. The area is 162. Set up an equation that could be solved to find the dimensions. Now, again, we know there's 2 dimensions here. Which one is the variable? Well, we know that it is 2 times as long as it is wide, but we don't know anything about how wide it is. So let's let the width be our variable. Let's call it w. Okay? So in our rectangle, I swear I drew a rectangle. In our rectangle, let's call the width w. It says that the length, it's 2 times as long as it is wide. So that length is 2 times the width. 2 times means we're going to put a 2w here for our length. And our area is 162. So area for a triangle is length times width. In this case, 162 equals w times 2w. And really, that would be enough. I mean, that's technically an equation, but just so we can set this up, 162 would equal, if we distributed here, 2w squared. And if I subtracted that 162 over, we'd say 2w squared minus 162 equal to 0 is the equation that we would be solving to figure out what our width would have to be. Okay? Now, if you had stopped at this step, I would totally have taken that as a correct answer. But if we were going to actually solve, we would want it in order and equal to 0. Okay? So hopefully you feel all right with that. All right, let's look at another type of example here. So these are translating problems. This is where we are literally just going to translate the words to an equation. I kind of like these ones, but you have to know key words. And we're going to go through some of these. Hopefully they won't be too terrible. So first, it says 3 times the square of a number is 5 less than 16 times the number, and we're trying to find the number. So let's try to translate here, okay? First it says we're looking for a number. What do we want to call it? You want to call the number x, n. I'm going to call my number n. So let's let this number be n, okay? So it says 3 times. 3 times means 3 is going to be multiplied by something, so I'm going to put it in parentheses because I don't know what it is yet. So 3 times, then it says the square of the number. So I'm multiplying 3 by the square of the number. So my number was n. The square of my number would be n squared. Okay? Then it says that is our equal sign. So is translates to equals. And then it says 5 less than. What does 5 less than mean? 5 less than means we have to take 5 away from something. We don't know what it is yet, so I'm leaving a little space there. So it's 5 less than, take 5 away from, and then lastly here it says 16 times the number. 16 times the number is going to be 16n. Okay, so if I just clean this up a little bit, 3 times n squared is 3n squared. 16 times n is just going to be 16n, and then I have a minus 5. So that is my equation. All I have left to do is solve it, okay? So I want everything on one side equal to 0, so I'm going to subtract over the 16n and add over the 5. So I'm going to have 3n squared, I'm going to have a negative 16n, and a positive 5 equal to 0. And then I'm going to use bottoms up. So 3 times 5 is going to give me 15. And let me change colors. Let's see, 3 times 5 is going to give me 15. I can use 15 and 1, if they're both negative, to multiply to 15 and add to negative 16. If I divide by 3, that's going to reduce. And so we have, as our factors, an n minus 5 and a 3n minus 1, which means our solutions are going to be positive 5, and then here we would have to add 1 and divide 3. And remember, it's the opposite of what we have here and here, so if you wanted a shortcut, you absolutely could. Alright, so we have two solutions here. Can we keep them both? Some of you might be like, oh, we don't want a fraction. Well, maybe we don't, but we're just looking for a number here. 5 is a number, 1/3 is a number, which means both of them are possible solutions. So we're going to answer this by saying that the number could be 5, or it could be 1/3. Both of those are possible solutions. Okay? Alright, hopefully that wasn't horrible. I don't know. Maybe for me and my skewed math teacher perspective. Sorry, I just want to scoot this up a little bit. Okay, let's try another one. So 9 more than the square of a number is 58. We want to find the number. Okay, I'm going to call my number n, although you can call your number whatever you want. So let's translate. First it says 9 more than, that means 9 plus or plus 9, either way, it doesn't matter the order you add. It says 9 more than the square of my number. So if my number is n, the square of my number would be n squared. And then there's my there's my equal sign. And then 58, that's pretty easy to translate. 58 is 58. Okay? So 9 plus n squared equals 58. That's the equation we're trying to solve. 9 plus n squared equals 58. So let's put this in order. N squared plus 9 equals 58. And we want it equal to 0. So we're going to subtract the 58 over. Make sure we're subtracting it from its like term. That gives me n squared minus 49 equal to 0. And hopefully you're seeing that's a difference of squares. N squared minus 7 squared, right? So this is going to factor into an n plus 7 and an n minus 7, which means n could be negative 7, n could be positive 7, or n could be plus minus 7. Now we want to make this an answer to this question, right? It says find the number. Well, these are both numbers. They both count then as solutions. So we're going to say our number could be positive or negative 7. The number could be 7 or negative 7. Alright, so here's another one that I would like for you to try if you're feeling up to it. Just a setup, no solving, just try the setup piece of it, okay? So pause the video if you're confident, or even semi-confident, or even if you're not. It's going to be good for you to try, okay? So let's see, 4 times the square of a number is 3 more than 5 times the number. Write an equation that could be solved to find the numbers. Numbers, I'm going to call it n. So it says 4 times, 4 is going to be multiplied by something, and it's being multiplied by the square of the number, so n squared, and there's my equal sign, my is, and then we have 3 more than, that's 3 plus, or plus 3, and then 5 times, 5 multiplied by, and lastly, running out of colors, my number. 5 times my number, 5n. So let me just clean this up, make it all uniform here. This is 4n squared equals 3 plus 5n. And if I just move these two terms over, get it in order equal to 0, 4n squared minus 5n minus 3 is the equation that we would solve to figure out the numbers that would work for this scenario. Okay? Alright, we got one left here. This is a consecutive integers problem. Consecutive means one after another. So consecutive is one after another, like 1, 2, 3, 4, 5. Okay, consecutive, one after another, like 1, 2, 3, 4, 5. These are consecutive numbers. So it says that Mary has 2 sons born in consecutive years. If the product of their ages is 342, how old are they? So Mary's got 2 sons born in consecutive years. We're trying to find their ages. So their ages are going to be consecutive if they're born in consecutive years. Okay? How old are they? That's our question. So we have son 1. We have son 1. And then we have son number 2, the first son and the second son. What are their ages? Well, let's say the first son is X. Well, we don't know the age of the second son either, just like we didn't know the base and the height or the length and the width, but we don't want to make 2 variables. Alright? So the second son, his age, we're going to have to put in terms of the first son's age, right? Well, let's just hypothetically say, let's say the first son was 21 years old. How old would the second one have to be? If he was born the very next year, he'd have to be 22, right? Or if he was 30, he'd be 31. Or if he was 45, he'd be 46. So if the first son is X years old, how old is the next son? Well, to get from 45 to 46, or 30 to 31, or 21 to 22, we're just adding 1. So X plus 1 would have to be his age. So if they're consecutive, they're 1 more every time we go down the list. So we're going to call the second son's age X plus 1. Now it says that their product of their ages is 342. Let me just do this in color-coded for you. The product of their ages would be X times X plus 1. Sorry, I'm going to change colors. The product of their ages would be X multiplied by X plus 1. Product means multiply. It says that is... It says it is 342. And there's our equation. Okay, if we distribute x squared plus an x, let's subtract the 342 over to make it equal to 0. And all we have to do is find the factors of this really ridiculously large number. Let's use green. 1 times negative 342. What are the factors? Well, that's a gigantic number. Okay, pull out the big guns for this one. Means the calculator. So 342. 42. Okay, so let's just try, right? Divide by 2. 171. That's not going to work. Divide by 3. We get 114. That's not going to work. Divide by 4. Decimal, no good. 5, no, obviously. 6 goes in 57 times. We're getting closer. 7, nope. 8, nope. 9, nope. So we have my list handy here. I know 10's not going to go in. 11's not going to go in. 12, no. 13, no. 14, no. We're just going to keep dividing, okay? 17, 18, oh, there you have it. 18 goes in 19 times. I know that's my pair because I was looking for a difference of 1. So calculator's helpful. And we're going to make the 18 negative, and dividing by 1 shows us our factors. So x minus 18 is a factor, x plus 19 is a factor, which means x is equal to 18 or negative 19, and x represents the age of the first son. Obviously, he can't be negative. We're not going to count that. So son 1, the first son, is 18 years old, and the next son is 19 years old. And 18 times 19, we saw that here, does give us a product of 342. but those are our son's ages, her son's ages. Okay? Alright, so hopefully these are manageable. What you're going to see in your practice assignment are the same types of word problems. I'm not going to throw anything out of left field. You'll see a geometric problem, you'll see a translate problem, and you may see the consecutive integer problem. Okay? So they're going to be tough. The first time through, if you don't do so well, just check the feedback on the problems. A lot of them on the feedback, I tried to really help you with the setup. But if you still find yourself struggling, then by all means reach out. I am here to help. Okay? Alright guys, take care.